Welcome to Spaceverse, your portal to cosmic adventures. Out in the vast, silent reaches of the cosmos, where stars are born and die in breathtaking displays, a remarkable scene unfolds, one that was once invisible to human eyes. Now, thanks to the extraordinary mid-infrared imaging power of the James Webb Space Telescope, the dusty rings of a planetary nebula known as NGC 1514 have been revealed in unprecedented detail. This is not just a picture, it's a glimpse into the final moments of a star's life. Witness the magic of cosmic dust being hurled into the void, the remnants of a star shedding its outer layers, flinging them across space like glowing ribbons in the dark. Come one, come all, to see what only Webb can show us. Thanks to Webb's unique ability to observe in the mid-infrared spectrum, astronomers now have the clearest, most detailed view ever captured of this planetary nebula. What appears as soft, fuzzy rings in this image are actually complex, tangled structures of dust, intricately woven and chaotically beautiful. The pinkish region near the center? That's not just color, it's a clue. Scientists believe the gaps and holes you see are signs that faster-moving streams of material have blasted through, punching out from the heart of the dying star system. But there's more. What looks like a single bright star at the center is actually two stars, locked in a gravitational dance. It's this binary system that likely sculpted the beautiful, swirling architecture we see today. These two stars have shaped this nebula together over thousands of years, and they'll continue to do so for thousands more. Before Webb, most of this material was invisible to us. We didn't know it was there. We couldn't see the full picture. Mike Ressler, a lead scientist on the Webb team, discovered the dusty rings of NGC 1514 back in 2010 using data from NASA's WISE mission. But even then, the image was just a whisper compared to what Webb can now reveal. With the mid-infrared instrument, MIRI, Webb delivers clarity unlike anything seen before. As Ressler said, we couldn't even detect most of this material before Webb, let alone see it so clearly. Now that clarity gives scientists a chance to study the violent, chaotic, and beautiful end stages of a star's life in detail, and gives us all a chance to marvel at the universe's artistry. This is the death of a star. This is the universe at work. And this is only the beginning of what James Webb will uncover. For at least 4,000 years, a cosmic masterpiece has been slowly taking shape, an evolving portrait painted not with brushstrokes but with gas, dust, and the delicate interplay of starlight. And even now, across the unfathomable reaches of space, it continues to transform, an artwork in motion destined to change for millennia to come. At the very center of this celestial scene, the James Webb Space Telescope captures what appears to be a single radiant star. But look closer, this is actually a pair of stars locked in a gravitational embrace. These two stars, hidden behind the iconic diffraction spikes that catch the eye in Webb's images, orbit one another in a tight, elongated dance that takes 9 years to complete. Surrounding them is a luminous arc of orange dust, a flowing ribbon of material shaped by forces both ancient and mysterious. And in this dynamic duo, one star plays a truly dramatic role. Once, it was a giant, much larger than our own sun. But over time, it began to change. In 2017, senior scientist David Jones, working with the Institute of Astrophysics in the Canary Islands, revealed a key piece of this puzzle. He confirmed that the heart of this structure, known as NGC 1514, harbors a binary star system. As the primary star aged, it ballooned in size, expelling its outer layers in a dense, slow-moving stellar wind. Eventually, the giant shed so much material that only its burning core remained, a white-hot remnant that would shrink into a white dwarf. During this dramatic transformation, the star's winds likely shaped the surrounding gas and dust into elegant, thin shells, structures that were sculpted as the winds shifted from violent gusts to a whisper. And then there's the shape. In Webb's crisp, infrared view, the nebula appears to pour outward at a slant, like light spilling from a tilted can. But this is an illusion. In reality, astronomers believe that NGC 1514 is more like a cosmic hourglass, its ends snip clean, leaving behind an open structure with a narrow middle. If you look closely at the orange dust patterns, you'll see a delicate V-shape in both the upper left and lower right corners, a visual hint at the nebula's pinched waistline. But why does it look this way? David Jones offered a compelling idea. During its most active phase, the primary star may have lost material so rapidly and in such volume that its companion star drew incredibly close, perhaps brushing near the surface. The gravitational interaction between them could have created chaos. Instead of forming a simple spherical shell, this chaotic ballet gave rise to rings, arcs, and complex forms, etched into space like the trails of an unseen sculptor's hand. And while the hourglass shape is the most prominent feature, there's even more hiding in plain sight. If you examine the space between the brighter arcs, you'll spot faint, slightly hazy clouds, ghostly wisps of orange dust floating in the void. These are the outer layers of the original star, now drifting slowly away, as if reluctant to let go. Out in the vast darkness of space, where dying stars paint the cosmos with their final breaths, lies a system of variegated elements, an ethereal relic of stellar evolution known as NGC 1514. What you're seeing here is not just a beautiful planetary nebula, but a mystery wrapped in dust and light. Recently, NASA's James Webb Space Telescope turned its powerful eye toward this complex structure and revealed something breathtaking. According to Webb's observations, the twin rings of the nebula aren't evenly illuminated. Instead, the light appears more diffuse toward the lower left and upper right edges, creating a ghostly, uneven glow. And the structure of those rings? Not smooth at all. They're rough, fuzzy even. Scientists believe they're made of ultra-fine, microscopic dust grains. Tiny, but significant. And when the searing ultraviolet light from the central white dwarf strikes those particles, they heat up just enough to glow in mid-infrared. Just enough for Webb to see them. But that's not all Webb saw. Inside the nebula's clumpy, pinkish core, especially around the rim of the bubble-like voids, the telescope detected something else: oxygen. Not evenly spread, but scattered in pockets along the edges. What's striking, though, is what's missing: carbon, and the more complex, smoke-like molecules built from it, known as polycyclic aromatic hydrocarbons. Usually common in planetary nebulae like this one, here they're nowhere to be found. Why? One theory points to the dynamics of the two stars at the heart of this system. As they orbit one another, their movement likely stirred up the ejected material, preventing more complex molecules from forming. The result? A simpler chemical composition, but one that lets more starlight pass through, illuminating the faint, misty rings we now see. And if you noticed a bright blue star at the lower left of the image with slightly smaller diffraction spikes than the main stars, no, it's not part of NGC 1514. That star is actually much closer to us. It's just photobombing this cosmic portrait. NGC 1514 isn't a recent discovery. It's been on astronomers' radars for centuries. Back in 1790, William Herschel observed this very object and noted something remarkable. It was the first deep sky object he couldn't resolve into individual stars. It looked cloudy, a revelation at the time. Now, with Webb's unmatched resolution and sensitivity, we're seeing that same cloudy form with stunning clarity, revealing layers of structure, material, and mystery that Herschel could only dream of. NGC 1514 lies some 1,500 light-years away in the constellation Taurus, a delicate reminder of the universe's ability to evolve, collapse, and create beauty in the aftermath. In the silence of space, this fading star still tells a story. And thanks to Webb, we're finally starting to understand it. If you enjoyed this journey through the stars, don't forget to like, subscribe, and keep looking up.